All right, guys, welcome back. So we have reached to the point where I have shown you that we are extracting the information from the table, and we are storing it into two different lists. One list is storing the header, and the other list is storing the data from under that header, right? So just for recall perspective, let's refresh our memories. Just adjust my screen a little bit, and then I think we're good. Yeah. All right. So if you can see in here, we have the header, which is number sign, employee, customer, order date, order total, and status. And the same thing in coming in here. The first one you can see is empty, and like I mentioned, it is considering that the navigation row as part of the table, and that's generally part of the ML algorithm. They are not that intelligent where they can differentiate which is the part of the actual table or which is not, but we can filter that if we want to, right? Because obviously, like you can see, the information in the header column is coming as null, so we know that that's something that we can safely ignore. The information is starting from the number sign, right? So number sign, employee, customer, order date, order total, and status. That's the header list, and that is purely Python list that where we are storing our information. And then if I can quickly scroll down, you can see the very first row, 53, Jain quotas, best for organic score, 29th of August 2023, 95.69. It extract that row. Excellent. And then the same thing, that's the second row, Consto, and that's the third, Wood Grove Bank. And the last but not the least is the fourth row, which Adventure Works cycle, right? So that all the information has been successfully extracted from the table, right? And we have that information available in the list, right? So just to make it simple, so what we're gonna do now, the next step for us, that we will add that information into our DynamoDB table that we have created in here, which is schemaless. Like at the moment, it only have the partition key. Okay, so come back to our Lambda function. Very first thing we're gonna so instead of putting everything together, that's gonna really I would say complicate our Lambda function coding from the understanding perspective. Like you can see, we have already put some logic in here, which is extracting the information from the document. So I'm going to modularize it. I'm going to create a separate function that will insert the data into the DynamoDB table, right? So what I'll do, let me quickly bring that function, and then I'll explain that function, that how we're gonna do it. And that's just the one version of the function. If you want, you can build your own version. No problem with that. I'm just building one that suits my requirements. So you can see the function is receiving the header row and the data row in terms of the list. And we're going to convert this data into JSON, because if we need to put the item in the DynamoDB table, it needs to be JSON, and JSON give you the flexibility where you can define or change the schema, or that in other words, you can see if you want to insert this schema-less information, right? So the information generally stay in the key value pair under the JSON. If you have a concept of JSON, is pretty similar concept. We have the key value pair where key show the column and the value show the actual value, right? So what we're gonna do, we're gonna actually generate the key value pair for all the column and the respective value, as we can see in this table, right? So what's going to happen? Employed colon Jan quota comma customer colon, then whatever value we have in here, order date colon 29 of August 2023, and the information continues till the JSON block has been completed, right? So that's why I'm passing these two. And now you can see, because I need to pass the partition column, so and that needs to be unique. One thing you remember, if you want to keep the value unique while you're processing, so once you insert the API of the JSON, sorry, of the DynamoDB is quite efficient. If it detects the key is already exists, instead of inserting, it's going to override the data. So be mindful of that once you are inserting the data and your partition key value is going to be the same, it's not going to add a new instance, it's going to override the previous instance, which is very dangerous in the production environment if you won't give a proper attention to that, right? So that's something you need to be mindful of. And I'm going to show you an example in a separate video, right? So I'm going to traverse the header list, because both lists are going to be same in length, right? And then all I need to extract the information from the corresponding index, right? So that's why I have defined the variable which gonna track the index of my my value from the list. So because you can see it start from here, it's going to be 0 1 2 3 4 5 6 indexes that I'm going to traverse, right? But my header, I can either go towards the numerical index, or I can use the for loop, which is going to extract each item from for my header list. And you can see that's what I did in here, right? One thing I have defined, so because I'm going to use the key value pair, so I'm going to use the dictionary that will store the key value pair, because that dictionary I'm going to pass to my put item method of the DynamoDB table reference, and that dictionary will automatically convert into the JSON and load it into my I would say into my DynamoDB table, right? So the function logic is pretty simple, like I mentioned. So the data item, what I'm doing with the data item, I'm just actually once I extract, I need extract the header information. I need to extract the corresponding value in some variable. So that's where I'm actually using the data item, where I'm storing the value into the variable temporarily, because as soon as it has been added into the dictionary, I don't need it. I can overwrite with the next value, right? So just for reference, the item variable, which is part of the for loop, is going to contain the item from the header list. The data item is going to store the actual value we are going to extract from the data list, right? So and based on the index, both will be symmetrical during the loop execution, right? Okay. So obviously, if the item is empty, that means I'm going to extract the navigation panel, or the column name is missing, which is not going to help me if I insert it into the DynamoDB table. So I'm going to ignore the whole operation. I'm not going to store it into my data dictionary, because obviously, if the key is missing, what's the point of storing the value in the dictionary? So you can see I have put a check that only do the operation under the loop if the item is not equal to empty, right? So in that way, I can extract the data item, whatever data item I have extracted. I'm going to store into the table row, which is a dictionary, and you can see I'm passing item as a key and data item as a value, right? Pretty straight programmatical concept. And then obviously I'm increasing the index, so I move to the next cell. right? So the operation will continue until unless my whole data dictionary, my whole dictionary is going to be prepared, and I called it table row because that dictionary is going to reflect to the row. So you can see that dictionary is going to reflect to this particular row, which I'm going to insert into my DynamoDB table, right? So that's pretty right. So once I have the whole dictionary, I have the whole data set ready, I'm going to insert it into my dictionary, and then I'm going to declare the object. Like I mentioned in the previous episode, we have already defined the object on our DynamoDB service through Boto3. That's how we work in the Python, and then I have passed the table name as a reference, and that table name is the table name that I have used to store the value, which I have defined in the environment variable section, right? So you can see how dynamically it translate, it's getting the value from my environment variable, storing into the table name, and that table name is going to use once I define the table reference on my DynamoDB table class, right? Now, once I have the table object ready, I can now use it to interact with the DynamoDB table on in my code, right? I can put the item, I can get the item, and I can perform all sort of operation using that object, right? So in this case, we are going to put the item into the DynamoDB table. So what I'm gonna do, I'm gonna actually call the put item, and you can see in the item I'm passing my table row as a value, and like I mentioned, it's a dictionary because a key value pair, so it align with the JSON format. So what's going to happen, the put item is going to accept it as a JSON value, and it create the row in the DynamoDB table, right? So let's see if we are able to get it working, but before that, we need to reference this function into our main code, right? So in here, at some point, we need to call this function, right? So I believe this is going to be up to this point, and I need to put a condition, and that condition will be, because we are not going to process it to every row, we can only process it once the row is greater than 1. And what's the equal to 1, and what's the logic? Because row index 0 will indicate that this is the header row. So header row, we are not going to insert it because header row itself means nothing. The header rows work with the data row to create the information for our DynamoDB table, right? Because header row only define the schema, but what we're gonna store against that schema, that is part of the data row, right? So you can see these two rows are going to combine to give us the true data set that we can insert back into DynamoDB table. And then obviously it's not only one row, every time the row will change, but header will stay or schema will stay static in this case. But if our schema is dynamic, we can handle that as well, because that's where the DynamoDB is really shine over the relational databases. All right. So just for the first round, what I'm gonna do, I'm just gonna hard code it for the index one. So what will happen? If our logic is correct, we're gonna see the first row where the row index is 1. That row will insert it into our DynamoDB table. All right. So let's see if we are able to do it. And then we are not doing anything fancy. All we are going to do, if the row index is 1, let's call that function that I've just recently explained and insert the row into DynamoDB table. Let me hit deploy to see if there is any error. All right, and let me hit test. All right, status goes 200. We have success, and let's see if we are able to see. There we go. So what we are doing, so let me quickly show you in here. Once we insert the item into the table, we are getting the response back, and that response will tell us whether the operation is successful or not. So if I come in here, there's only one instance where we are getting this row, where we have the response metadata, because I'm printing it, and you can see response code is 200, right? With any other a row that we have extracted, there is no row like this. There's no response row, because I only push the row, push it for row index 1, right? Before I can go back, because I've already seen that the operation is successful. So if I come in here and explore the table of my explore the item of my table, so I should be able to see the records, right? So let's wait for it to scan. Hopefully it won't take much time. It's only one row. Just come in here and restart it here. Exportable items should be quick now. By the way, I have this small screen in here where I'm recording it, so sometimes the adjustment is really weird based on what I can do. Yeah, I think that will give me more space. So let it search. It's still searching it. Hopefully it will find the record. Just reset that. All right. So sometimes that's the browser, because I'm using Chrome and there are many instances open on my screen. So these weird things happen. But the good thing, like you can see, we have our information stored into the table, right? So that's the first row. Let me quickly show you in here. 53 giant quotas, row number 1. Best for your organic CC date, and then we have the total and status new, right? So you can see all the information is nicely stored. And one thing, like I mentioned from the start, you can see, although we only define the employee order ID, which is the partition key, but you can see all the attributes it has created by itself, right? So that's where it's really shine over the relational database system, right? You can see that everything has been created nicely into the table, right? So our first test is good. Like we have extracted one row. What I'm gonna do, let me just select it and go action and delete this item, because what I'm going to do now, we're gonna bulk it. So what does it mean? So instead of doing it only for row index 1, I'm going to do it where the row index is going to greater than and equal to 1. So beside the header row, it's going to run and insert all the rows into the DynamoDB table that we have created it, right? So let's deploy it and hit the test, and we'll see if we are able to. So one thing I'm going to show you in here before I jump back into the DynamoDB interface. So now each row is going to show you the response metadata, and in the each response metadata, we're going to see the HTTP status code, which give us the idea whether our insertion is successful or not. So the first row has been entered, the second row has been entered, and now you can see each row has the response because I took the condition of the index out. So it is inserting each and every row. So the third row, for every row has been inserted, right? So now theoretically, if I check in here, 1, 2, 3, we should have 4 rows extracted and loaded into our DynamoDB table, right? So now let's see if I can run it now. Excellent. So I can see, let me quickly show you in here. We have 53 giant quotas, 42 giant quotas, and 48 and we have 33, right? Yeah, 48, 42, and 33. All record has been nicely created, which has been extracted from the image, which is a very, very powerful concept. Like previously, we have to manually key in that information, but now you can imagine with the machine learning algorithm and the services that AWS providing, something that requires some manual effort. Now you can fully automate that concept, and obviously we can define that, we can extort that information, and later we can refine it, right? But you can, that's give you the idea how the automation work and how it can take out the manual effort out from the many business processes, right? So that's the end-to-end solution that we were expecting to see as part of this architecture diagram. And like I mentioned, if you remember, I think that's the one that I'm going to actually show you how we can load the information into the DynamoDB. By the way, we can load the same information into the S3 bucket in the CSV format or any other, or even the JSON format. That's not a problem. We can keep the information there as well and then process from there. But obviously, DynamoDB is more like, we can use it later as a source to our warehousing or any other system, right? It's much easier to extract from the DynamoDB if you have a preference to use the database instead of working with the plain file, right? So I believe the architecture is fully realized, and you have the full conceptual as well as the practical overview how the whole thing works from end to end, right? I'm gonna upload that code into the Git repo. I'm gonna put the link in the description, so you can download and play the code by yourself. Feel free to reach out if you have any question, and put any comment if you would like to know more. Otherwise, thanks for watching, and I'm gonna see you in the next series with other interesting problem. Thank you.